So we're going to continue talking about functions, and now we're going to talk about something called inverse functions. But before we do that, let's fill in the tables here for f of x and g of x. Right here we have f of x equals 2x. So if we use the values that are given to us here, and we use -1, then f of x is -2. If we use 0, f of x is 0, and if we use 1, f of x is 2. Now if we come over and look at our g of x, we see that it's g of x equals 1 over 2x, so 1/2 x. So we'll use the table, the values they give us here. We plug in -2, we'd get -1. We plug in 0, we'd get 0. And we plug in 2, we'd get 1. And the question here is, what do you notice? So hopefully you see that the x values and the y values have switched places. So -1, -2 became -2, -1. So hopefully you see that we switched the x and the y values. And that means that g of x is the inverse of f of x. Okay, so two functions are inverse relations if they undo each other. So if you look at the formulas that you know from chemistry and probably from physics for Fahrenheit and Celsius, this formula converts from Celsius to Fahrenheit, and this formula converts back from Fahrenheit to Celsius. These two functions, even though you may not have known it, are inverses of each other. An inverse relation exists if and only if one relation contains point AB and the other relation contains the point BA. So again, we see that the x value and the y value just get switched in an inverse. So if the inverse relation of a function is a function, it's called an inverse function. And what that means is that if we know f of x and we know all the points, then we can graph the inverse function. That's how you say this, inverse of f of x, by graphing all those points that we knew, but just switching the letters. So instead of x and y, we graph y and x. And the inverse is denoted by this, f minus 1 of x. But note that does not mean reciprocal, so that's not this. So don't think that that's what that -1 means. All right, so hopefully you remember with functions we had something called a vertical line test. Well, with inverse functions we have something called a horizontal line test. And it says that a function, so any function, has an inverse function if and only if each horizontal line intersects the graph of the function at most one point. So you see in this picture, when we draw a horizontal line down across the bottom here, it intersects our graph right there. So we know that this function does have an inverse, and we can find it. So if a function passes the horizontal line test, then that function f of x is called a one-to-one function. I don't know what this graph is doing up here, but hopefully it's not in your notes. Okay, a function is one-to-one if for every y value there's exactly one x value. If a function has an inverse, then it's a one-to-one function. So let's take a look at some inverses and how they work. So example 1, let f of x equal 3x minus 1. So we're going to do part A, which says make a table of values, sketch the graph of f of x and y equals x. So first let's do our table of values. So now we've been making x, y tables, so we're going to make an x f of x table. Same thing, just going to start calling it f of x more often than y. So let's pick some numbers. So we'll pick -1, 0, and 1, just because those are easy numbers. So we plug in -1 to f of x. That gives us Negative 3 minus 1, so negative 4. And then let's plug in 0, that will give us negative 1. And then we plug in 1, will give us 2. So it said here, make a table of values and sketch the graph of f of x and y equals x. So let's do f of x. So f of x is going to be negative 1, negative 4, 0, negative 1, and 1, positive 2. But then it also said to sketch the graph of y equals x. Well, hopefully, from our parent function quiz, you know that the graph of y equals x is this one. It goes right through the origin, has a slope of up 1 over 1. All the points are 1, 1, 2, 2, 3, 3, 4, 4. So hopefully you're familiar with that one. And then to graph our f of x, that's the blue line, or the blue dots. Okay, so that's right there. And now, the reason that they had us graph the line y equals x, you'll see in a minute with regards to an inverse. So let's go to part B. It says, use the graph to determine whether or not f of x is a one-to-one function. Well, we just said that if it passes a horizontal line test, so it only intersects it at one point, then it is a one-to-one function. So we'll say it is one-to-one. We can even say check, it's one-to-one. Now it says, if so, then graph the inverse function of f of x. So to do the inverse, we did f negative 1 of x, right? So to do our inverse function, we need to do what we said and switch the x and the y values. So instead of y equals 3x minus 1, we're going to write x equals 3y minus 1. Remember, we just go and we switch the x and the y, just switch places. So plus 1, x plus 1 equals 3y. Divide both sides by 3. And we'll get that x plus 1 over 3 equals y is our inverse f of x. So instead of the y, we'll just put inverse f of x. And then we're going to make our table. Pick some points. So let's pick, how about negative 4, negative 1, and 2? You might think, well, why would you pick those points randomly? Well, let's plug it in and see what happens. So negative 4 plus 1 is negative 3, divided by 3 is negative 1. Negative 1 plus 1 is 0, divided by 3 is 0. And 2 plus 1 is 3, divided by 3 is 1. So maybe you noticed our tables look the same, except the x and y values have switched. So if we go to plot these, negative 4, negative 1, negative 1, 0, 2, 1. When we graph them, we see that they intersect each other on the line y equals x. And it almost looks like if you folded the graph along this line y equals x, that this red part would land on this blue part, and this red part would land on this blue part, and they would kind of swap places, and that's exactly what happens. The x's and the y's swap places. So another thing to notice here, doesn't show up so much on this, but the domain of f of x is negative infinity to positive infinity, and the range is negative infinity to positive infinity. Well, we come over here to our f prime of x, its domain is also negative infinity to positive infinity, and its range, you can see it on the graph, negative infinity to positive infinity. So just leave that there and let's go down to the next one and see what happens. So now we're on to example 2. Let f of x equal square root of x minus 3. So we're going to make a table of values, sketch the graph of f of x and y equals x. So f of x. So we have x and f of x. So we're going to make a table of values and sketch the graph of f of x and y equals x. So let's start with x and f of x. Make our table of values. So I want to pick some numbers that are going to work out in here, right? So hopefully you know that we need to pick numbers 3 or higher and 7. So we'll plug this in and get 3 minus 3, the square root of 0 is 0. 4 minus 3, the square root of 1 is 1. And 7 minus 3, the square root of 4 is 2. So something to note here about f of x is the domain, you should know, is 3 to infinity. And the range, you should also know, is 0 to infinity, because our graph can't go lower than 0 on the y-axis. Now, is this a one-to-one function, part B? Well, we need to graph it first. So we do 1, 2, 3, 0, 4, 1, 7, 2. So that's this one that you're used to seeing, right? That's the square root function. So now we're going to do x equals square root of y minus 3. We're switching the x's and the y's to find the inverse. So we need to square both sides, so we get x squared equals y minus 3 plus 3 plus 3. X squared plus 3 is f prime, or the inverse of f of x. So make a table. X, f inverse of x, inverse of f of x. And we start picking points. So what points do you think we should pick? How about 0, 1, and 2? So we plug in 0. We get 0 squared plus 3 is 3. 1 squared plus 3 is 4. 2 squared plus 3 is 7. And you can see we got the same numbers. They just switch places. So let's graph this and see what it looks like. 0, 3, 1, 4, and 2, 7. Okay, so one thing we forgot to do was this, graph the line y equals x. So we'll do that real quick. Remember, it goes right through the middle like that. And so hopefully you can see that if we folded this graph in half along this diagonal line here, that this blue graph and this red graph would land right on top of each other. So that's how you know that you've found the inverse. But let's look at what's the domain here of our f prime of x. So the domain, you can look at the graph, is from 0 to infinity. And the range, we can look at the graph, from negative 3, right here, negative, or positive 3, I'm sorry, to infinity. So you can see that the domain and range just switch. And remember, it's because we switched the x and the y values. They all traded places. So it's kind of easy to figure out. If you see one of these, you can find the domains pretty easy. All right, graph the following functions to determine whether or not it has an inverse. Well, we're not going to spend all day doing that. So the way I want you to do those is in the calculator. So when you graph this one, looks like this. When you graph this one, looks like this. And when you graph this one, looks like this. So real quickly, we want to know, do these functions have an inverse? Well, the test is a horizontal line test. So no, yes, no. And that's it for inverse functions for today.